All right, now we're starting 9.3 in algebra, solving quadratic equations, specifically by using square roots. So here's an example of solving a quadratic equation, 3x squared minus 27. What makes it quadratic is the x squared part, but it's equal to 0. Whenever you're solving a quadratic equation using square roots, we want to isolate whatever is being squared, in this case, x squared. So we use inverse operations. We could add 27 to each side. Then it's 3x squared is equal to 0 plus 27 is 27. To isolate x squared, divide each side by 3. Then x squared is equal to 27 divided by 3 is 9. Now we need to undo the square. So we undo the square by taking the square root. That undoes a square, but take the square root of each side. It seems pretty basic. I take the square root of the left side, I take the square root of the right side. When you take the square root of a constant or just a number, you have to use both the positive and negative square root. So take both the positive and negative. That's what this little symbol means, the plus on top and the minus on the bottom, square root of the constant. That's always going to be the case. And the reason why that's the case is if you take the square root of 9, that's 3. 3 squared is 9 if I were to check my answer, but also negative 3 squared is 9. That's really why you have to take the positive and negative square root. So x is positive or negative 3. You can write it out separately if you want. It would look like this: x equals 3, x equals negative 3. It's just a little bit quicker to use the symbol positive or negative. I didn't mention on the left side here, when we're taking the square root of x squared, the square root just undoes the square. So really there's two solutions, whether I write it like this or this. You don't have to write it both ways, but you do have to have both of the solutions, positive 3 and negative 3. All right, so here's my next example. X squared minus 10 is equal to 10. I want to solve that. And right now in 9.3, all we're doing is solving by square roots. So I need to isolate x squared, add 10 to each side. And then what we end up with, originally that was supposed to be negative 10. So I could add 10 to each side, get x squared is equal to negative 10 plus 10 is 0. To undo the square, I take the square root. This is your constant. Take both the positive and negative square roots. Then x is equal to both positive 0 and negative 0. Positive 0 is the same as negative 0. So here, instead of writing out two solutions, positive 0 and negative 0, they're the same thing. So there's actually only one solution. X is equal to 0. All right, and then on my next example, I want to solve the quadratic equation, negative 5x squared plus 11 is equal to 16. So I need to isolate the x squared term first. So I can subtract 11 from each side. Then it's negative 5x squared is equal to 16 minus 11 is 5. To isolate x squared, divide each side by negative 5. Here's what we end up with. X squared is equal to negative 1. If I try to take the square root of each side, take the square root of the left side, square root of the right side. This is a constant. Take the positive and negative square root. Say you try that on your calculator, the square root of negative 1. It'll say error because we're trying to take the square root of a negative number. In other words, we're trying to find any number squared that equals negative 1. If you square any real number, you square a positive number, you get a positive. If you square a negative number, you still get a positive. The only time where you square a number and you don't get a positive is if you square 0. So here, there's no solutions or no real solutions. So what we've taken a look at on the 3 examples, if you take the square root of 0, you only get one solution. If you take the square root of a positive number, going back to my first example, you get 2 solutions. And then if you take the square root of a negative number, you actually get no solutions.